Hi everyone, in this video we are going to discuss the P3 difficult paper set 2. So let's start with question 1. Okay, solve the inequality modulus 2x minus 7 lesser than 2x minus 9 in modulus as well. Okay, so for all the modulus question, you have both side modulus and it involves inequality. Then the best way, the easiest way to do that is to do squaring. Okay, so let's try to use that. So first approach. Let's try to do just square the both side. So 2x minus 7 lesser than 2x minus 9. Okay, so just square the both side. 2x minus 7 square lesser than 2x minus 9 square. Okay, so let's expand it. So 4x square minus 14, that's 28, and then plus 49 lesser than 4x squared, 18, so 36, and then plus 81. Okay, so let's try to do some quick calculations. So 4 minus 4, you get 0, then 36, you move to the front, so you're left with 8x, so 49, bring to the back, so you have 32. Okay, so in this case, then we'll be able to get x lesser than 4. As simple as that. Okay, so the marks will be given for the first one you do your squaring, then after that your last answer. Okay, so basically the 3 marks for this question. So if you do not want to use squaring, then the other method that you can try to use is use find the critical value first. But as what I say, if you need to do squaring, then just move on for squaring. That will be the most easiest way to do that. So if let's say you do not want, you want to try other way, then the troublesome thing that you need to check your answer after that lah. So the first thing that you can try to do is modulus 2x 7 and then lesser than 2x minus 9. Okay, so I'm not going to explain further for the positive, negative. You need to change the sign, no need to change the sign. You can refer to the previous video. But the thing that you can only solve is to solve equal to only. So which means it will be 2x minus 7 equal to 2x minus 9. Or the other thing is 2x minus 7 equal to negative 2x minus 9. So for the first one, you realize that you will get 2x minus 2x, right? So that's why for this case, you can't actually solve it. So no solution for this part. Then after that, for the second one, when you try to solve it, then you will be able to get 2x minus 7 equal to negative 2x plus 9. So in this case, after you move here, then you get 4x equal to 16. So in this case, you can get x equals to 4. So x equals to 4 is like your critical value, because in this case, you wouldn't be able to know which is the part that is. Because modulus we talk about, you change a negative number to positive. So that's going to change your sign. So that is why you can only find x equals to 4. Then after that, you need to put it back to the equation and check whether you need to do greater than or lesser than. So for example, you can try to imagine, let's try to imagine if you put 5, okay? So if you put in 5, then you'll realize that 5 times 2, then what do you get? So yeah, this is the checking part if you decided to do this method. So yeah, if you ask me, then of course go with the first one. Then the thing that you need to check is you need to get a number that is lesser than 4, and you get a number that's greater than 4 and lesser than 4. So which means maybe you can try to check x equals to 5 and x equals to 3. Okay, so in this case, you'll realize if let's say you substitute 5, right, then what do you get? 2, 5 minus 7 lesser than 2, 5 minus 9. So you can try to check and see if let's say it's 5, right, then you get 3. So is 3 lesser than 1? So the answer is no. So that's why x cannot be greater than 4. So you try to check if let's say it's 3, then which means 2, 3 minus 7 and then lesser than 2, 3 minus 9. So in this case, then what you can see here is 2 times 3, you get 6, so negative 1. So modulus, then you get 1. So 2 times 3, 6, 6 minus 9, negative 3. So modulus, you get 3. So 3 is greater than 1. So that's why this is correct. So that's why your last answer here will be equal to x should be lesser than 4, which you get the exactly same thing. Okay. So if you are using this method, then the marks that you will be given will be the first one you need to know, you need to do positive and negative. So that give you the method mark. Then after that, you realize that has no solution. If you get the critical value here, you get another A1. Then after that, your last answer. Okay, so it's the same thing, which give you 3 marks as well. But yeah, please, if you know how to do them, please go move on to the number 1 method lah. That's much easier. Okay, so now let's look at the second one, B. Find the largest integer n satisfying the inequality 2 ln n minus 7, 2 ln n minus 9. So you'll realize here that it's just the ln n substituting or replacing the x here. So which means in this case, the first thing that you will need to realize here is the ln n here. Ln n here is basically representing by the x. So which means the first thing that you should be able to know is ln 4 must be lesser than 4 because x is lesser than 4. Okay, I hope that you get what I mean. So yeah, let me just try to copy down everything. So 2x minus 7, 2x minus 9. Okay, so for this thing, we are able to get x is lesser than 4, right? So for this question, the question want us to find what's the n if let's say 2 ln n minus 7 lesser than 2 ln n minus 9. So that's why you see they are basically the same thing. It's just that the x is substituted by ln n now. So that's why which means that ln n should be lesser than 4. Okay, then you continue to solve and find what is the largest value of n. So ln, go to the other side, then it will be E4. Okay, so you can just use your calculator and you'll be able to get 54.598. Okay, so n is any number that is lesser than 54.598. So the largest number of n that you can accept within the range is 54. Okay, largest n equal to 54. Alright, so for this question, 2 marks. So the first mark is you need to realize that this thing is lesser than 4. So you get 1 mark over here. Then after that, your last answer, you get 1 mark. So that's 2 marks. Okay, so now let's look at question 2. Okay, number 2, the complex number u and v are given by u equals to 1 plus 2 square root 3i and v equals to 3 plus 2i. In an Argand diagram, u and v are represented by the points A and B. Okay, so I've prepared the Argand diagram so it's easier for me to explain. If you can imagine everything in your mind, then you can do that. But I guess for this question, it's pretty difficult. So that's why try to draw it, then you can visualize everything in a diagram, then it's going to be much easier. Okay, so in this thing, let's try to label the complex number first. So we have 1 plus 2 square root 3. 2 square root 3 is roughly 3.5. So this is our u here, so which is represented by the point A. Okay, so this is 1 and then this is 2 square root 3. Okay, so now for V is represented by point B. So it's 3 and 2. So x 3, then y here is 2. Alright, so we got our 2 points U and V here. So the third point C lies in the first quadrant and is such that BC equals to 2AB and angle ABC equals to 90. Okay, so you should know where is first quadrant. Then after that, BC equals to 2AB, which means the distance between the point B and C is going to be double of the distance of A and B. And the question gives us that ABC is 90 degree. So which means there are 2 possibilities that you can place your C. It's either you're going up 90 degree like what I have drawn here. The second thing is going down 90 degree. But in this case, the question tells us that the third point C lies in the first quadrant. So you can try to imagine or you can try to do some quick calculation, and you should realize here is that the distance for you to be double of the distance of AB couldn't be in this quadrant anymore if you are going down 90 degree. So that's why your C is not in fourth quadrant, right? So it should be going up. Okay, so in this case, then this will be our draft, and you roughly know that C is here. And the distance here is like double of this one. So if let's say this is 1, then this is going to cut to, this is 1 AB, then the other AB. Okay, so now the question wants us to find out what is the complex number Z represented by C. Okay, so I'll say this is more like a non-conventional question of complex number. the thing that you need is some kind of general knowledge that you learned previously about something like rotation, and you understand how to deal with coordinate geometry. It doesn't so much about complex number actually. Okay, so yeah, I hope that I can explain it like you can understand it. So let me know if let's say you can't understand it after this. Okay, so basically this is our imaginary numbers and then real number. Okay, so the first thing that we might need to do is we need to find out what is the distance or what is the displacement that take place for you to move from A to B. Okay, can we do that? So which means that we try to find out like how many unit for you to move from A to B, then how many unit in X, then how many unit in Y. So in this case, we can try to do from A to B. You try to treat it like a vector, I would say. So from point A to point B, so we try to use the point B to minus of point A. So in this case, then we have 3 plus 2i, okay, and then minus of 1 plus 2 square root 3i. Okay, so this will allows us to get the answer of 3 minus 1, you have 2, and then plus 2 minus 2 square root 3i. Okay, so which means by looking at this picture, right, you should be able to realize that also for you to move from A to B, you need to go to your right hand side for 2 unit, then you need to go down for 2 minus 2 square root 3 unit. So that's why, or if you try to press this in your calculator, you will get like negative 1.5. So 2 square root 3 is like 3.5. So 2 minus 3.5 is like negative 1.5 plus. So it's like going down 1.5 unit. Okay, you get what I mean, right? Okay, so now let's try to do a very quick, go through a very brief idea before we move on to the next part of the explanation. Okay, I want you to try to imagine previously when you try to learn something like rotation, right? If this is our axis, okay, if this is the origin, if I have a point here, maybe I try to give this as okay, negative 3 and 2. Okay, so can you tell me what happened if let's say I try to rotate this point 90-degree clockwise? So you move there for 90-degree. So can you tell me what's the coordinate here? So we know 90-degree, it will be somewhere here. Am I right? So when you try to find the coordinate here, you should be able to get 2 and 3. So which means that you should be realized that the one that, okay, like here, this is basically your x-axis is negative 3, so this is 2. Okay, so you imagine what you try to do when you try to rotate everything, right? This thing will eventually become the height of this thing. So that's why this will give you a 3. Then this thing, when you try to rotate 90-degree, then it's going to be like here, like your 2. So that's why you will end up here, which means your x will become your y will become your x kind of thing. Okay, so this is regarding to the origin. So let's try to do the same idea in this thing by treating this as our origin. So you can imagine that from the working that we did just now, right? We know that from A to B, what happened here is that you would go down for like 2 minus 2 square root 3. Okay, then after that for this thing, what you will try to do is you go to the right hand side for 2. So like what I said just now, so what happened is that this thing will try to the x will become the y will become the x. So which means when you try to move, right, what is a thing that you can try to get this point? Because why we are doing this point, because of we know that it's going to be double. So which means for me to move, rotate 90-degree over here is going to be from here to here is going to be 2 minus 2 square root 3. Am I right? Okay, but then this thing, because you are going down, so that's why this is a negative number, but this one you are going right, so you are going to negative the whole thing here. Then after that, this thing you are going up, right? So that's why it's still positive 2, so going up as 2. I hope that you get what I mean. Then after that, you need to repeat the same thing again for you to get to this point, because it's going to be double of the distance here. So how do you get to that answer? So two things that you can try to do. The first one is you can multiply by 2 first with this thing. So 2 and then multiply with what we have here. Okay, so this become our x already, right? So that's why minus 2 square root 3. Okay, and then for this part is going to be plus 2i. Alright, so after we get this, then we can multiply them, so times 2, and what we get here is negative 4 times 4 square root 3, okay, and then plus 4i. Alright, I hope that you are still following for now. Okay, so now let's continue to the next part. So which means that for us to reach this point, we will need to displace negative 4 minus 4 square root 3 and then plus 4 in the y direction. So which means we might need to use this coordinate, then plus how many we need to displace, then we can get the last answer. So which means C will be equal to our b. What is our coordinate for b already? Is 3 plus 2i. Okay, so that's why 3 plus 2i, and then plus with what we want to displace here, so negative. So actually you can just, yeah, 4 square root 3 minus 4, okay, and minus plus 4i. Sorry for that. Okay, I'm just rearranging this here, negative 4 and then plus 4 square root 3. So 4 square root 3 minus 4 lah. Okay, so now let's try to simplify it. So 3 plus 4 square root 3 minus 4. So we have 4 square root 3 minus 1. Okay, and then after that for the I part, let me try to write properly, 1. Okay, then after that for the I part, what do we have? So 2 plus 4. So we have plus 6i. Okay, so this will be our last answer, 4 square root 3 minus 1 plus 6i. Okay, so this is the position for C. I hope that you can get what I mean. Basically, if you can get this, then you should be able to get this. It's not so much about complex number actually, it's more on like how you translate, how you yeah, you can translate or rotate something, then after that how you displace the thing in coordinate geometry, then double the thing. Okay, then you'll be able to get the answer. So for this question, the marks is 4 marks here. So the marks will be given the first one if you are able to get this thing. So if you are doing it in the other direction also can. Okay, but that will be less helpful now, which means, you know, when we try to do rotation, then we try to treat this as our center. So that's why we try to, find out how do you what is a displacement that you take for you from A to B. So that's the idea. So we get the first one, then you will be able to multiply this thing, then you can get the second mark, then you plus to your answer, you get the third mark, and after that your last answer. Okay, so this thing give you 4 marks. Alright, so I'll try to spend some time to understand from that. If you still have any question, then yeah, we can try to discuss it in personal chat or in the consultation hour. Okay, now let's move on to number 3. Alright, question 3. The equation of the curve is y equals to e to the power of negative 2x tangent x for x is in the range of 0 to 1 over 2 pi. Okay, so the question wants us to find the dy dx, the derivative, and show that it can be written in this form. So now let's try to do our differentiation first. So this is for A. So y equal to e power negative 2x and tangent x. Okay, so obviously we need to do product rule, so u and v, right? So that's why dy dx will be equal to, so I guess you should be quite familiar with this, so I'll straight away do that. Alright, so in this case, so let's do uv prime. So u, okay, v prime, so we have second square x. Okay, then after that plus u prime, so we have negative 2e, negative 2x, and then tangent x. Okay, so that's basically the differentiation part. So now we need to do our rearrangement, so to show that this derivative can be written in this form. So you can see the difference, that the first thing that we might need to do is that second square here. So that's why we might need to change it to tangent. Okay, then you can see that's factorization. Then I guess we can try to do it in this step already. So e negative 2x. So in this case, I'm going to straight away to change this to 1 plus tangent square. Okay, so since I already do factorization, so in this case, I only left with negative 2 tangent x. Alright, so let's try to do some rearrangement. Negative 2x and then tangent square x minus 2 tangent x plus 1. Okay, then we can do a bit of factorization. So in this case, I guess 1, 1. Yeah, so it's going to be tangent x minus 1 square. Okay, so but yeah, we need to write it in this form, so which means it's going to be e negative 2x and then negative 1 plus tangent x squared. Okay, so this is how we get to our answer. Okay, so now B, explain why the gradient of the curve is never negative. Okay, so which means we'll need to show that this gradient is always positive, or I mean greater or equals to 0 lah, that it will never be negative. Okay, so for this part, we have dy dx equal to e negative 2x and then 1 my negative 1 plus tangent x squared. Okay, so in this case, we know that negative 1 plus, sorry, why do I keep on miss that up? Okay, so negative 1 plus tangent x squared. Okay, so this thing will always be what is the number here. So tangent x can be any positive number basically. Then after that, no matter what you get inside here, it should be a positive number, right? So this thing will be greater or equals to 0. And then for exponential e negative 2x is going to be a number that is greater than 0. It will never be 0, but it will be certainly be positive. This is exponential function, right? Then after that, when you try to multiply them put together, so e negative 2x and then negative 1 plus tangent x squared. So this thing will certainly be greater or equals to 0 lah. So dy dx will be greater or equals to 0, so that's why never negative. Okay, so that's how you can answer this question. Yeah, so why the gradient of the graph is never negative. Okay, C, find the value of x for which the gradient is the least. Okay, so in this case, we say that it must be greater or equals to 0, right? So the least gradient that we can get is basically 0 lah. So which means when dy dx equals to 0. So this is like when the gradient is the least. Okay, so we need to solve this. So E negative 2x negative 1 plus tangent x squared is equal to 0. So we know that e negative 2x can never be 0, so that's why no solution here. Then after that, for the other part, we have negative 1 plus tangent x squared equals to 0. Okay, so in this case, we have square, you move it over the other side, square root of 0, you still get 0. So tangent x will be equal to 1. So let's try to see for this question, the question 1, x in between 0 and 1 over 2 pi. Okay, so you can straight away just use your, tangent should be 45. So that's why x, the answer is given in radian, right? Yeah, so the range is given in radian, so that's why we try to answer in radian as well. So pi over 4 radian. Okay, so this will be our only answer here. Okay, so let's try to see how marks is allocated for this question. So you need to use product rule or quotient rule. So okay, let's try to look at it one by one. The first one, if you know how to differentiate exponential, you get B1 here. So you'll be if you get everything here correctly, then if you know how to apply product rule here, then you get your M1. Then after that, the next one is you get the correct derivative in any form. So which mean in this case lah, you are able to get the whole thing correct. You use product rule and you get everything correct, then you can get A1. Okay, so M1 and A1 basically referring to the same thing. Then when you try to use trigger identity to change the second, then you can get M1. Then you continue until you do factorization and get to the required form, then you get A1. Okay, so this is 5 marks. Okay, then continue for B. So you just need to justify. So the idea of justify is if let's say, so yeah, which means it's basically these three things lah. So make sure that you write, or after you square, then you should get greater or equals to 0. Exponential should be greater than 0. So when you times them together, it should be greater than n, or greater or equals to 0. Okay, so that give you B1. Okay, so that's 1 mark. Okay, then after that, the last one, they doesn't really need, yeah, so it's only a 1 mark question. Yeah, so the marks only given if you get your last answer here, so which is your B1. Okay, so this question is 1 mark. Alright, so that's basically question 3. So now let's move on question 4. Okay, question 4. With respect to the origin O, the position vectors of 2 point A and B are given as below. OA equals to this, OB equals to this. So the point P lies on the line through A and B, and AP equals to lambda AB. So show that OP is equals to this. So let's try to solve it. Okay, so A. So since you are given for AP, then the easiest way to do this is OA and plus AP. Okay, so AP is given lambda AB. Then we need to find AB from the information that's given here. So in this case, we will use AO plus OB. Okay, so let's try to write in matrix. Then I guess it will be easier for us to look at it. So 1, 2, 2 plus lambda. So so -1, -2, -2, OB is 3, 4, and K is 0. Okay, so after we get this, then let's combine this part. So we have 1, 2, 2 plus lambda. So -1 plus 3, so we have 2, 2, and -2. Okay, so now let's try to write it in the way that we need to show it. So we have 1 plus 2 lambda I, and then plus 2 plus 2 lambda j, and the last one we have 2 minus 2 lambda k. Okay, so that's exactly the same. So that's why you got the first answer. Okay, so now B, by equating the expression for cos AOP and cos BOP in terms of lambda, so find the value of lambda for which OP bisects the angle for OAB. Okay, so in this case, you might need to know, okay, for example, we know this is the line for, okay, so you can imagine this is AOP. Okay, so for us to use the, when you try to look at the costing, then you should know that you need to do the scalar product thing. So for scalar product, then you should use OA and then OP lah. So in this case, you are doing OBOP. So that's why it's going to be OB and then OP. Okay, so that's the idea. So for the first one, if you want to change it, then you can just try to write the thing first. So which means that we know if let's say you have vector A multiply vector B, okay, and then it will be equal to modulus A and then modulus B and cos theta, right? So if you were to write cos theta at the front, then it will be cos theta should be equal to A times B and then over modulus AB. Okay, so this is just for explanation in case you do not know how to do that. So let's start with the first one, cos AOP. Okay, so cos AOP. Yeah, this thing is going to look a little bit messy, yeah? So I hope that you can, get used with it. So cos AOP, then the thing that you'll be using is OA and OP. So which means is OA dot OP over modulus for OA multiply the modulus of OP. Okay, so let's start with OA first. So we have OA already, which is 1, 2, 2. Same thing, you can try to use matrix or yeah, let's try to write down everything here first. 1, 2, 2. And then this place we have OP. So OP is what we got from part A, so which means it's the whole thing here. So 1 plus 2 lambda, 2 plus 2 lambda, 2 minus 2 lambda. Okay, then over for the modulus part, then we have OA. So this is the same thing, but we are finding the magnitude. So 1 square plus 2 square plus 2 square. Then multiply. So this thing is going to be longer. So 1 plus 2 lambda square plus 2 plus 2 lambda square plus 2 minus 2 lambda square. Okay, now I need to continue to do that. So for this one, it's going to be the dot product thing lah. So 1, you can straight away multiply, I guess. So you will get 1 plus 2 lambda, and then 4 plus 4 lambda plus 4 minus 4 lambda. So for the magnitude, then we have 1 plus 4 plus 4, that's square root 9, that gives us 3. And then for this part, oh, you need to expand it. Okay, 3. It's going to be a long thing. Okay, so 1 plus 4 pi plus 4 pi, sorry, it's not pi, 4 lambda square, and then plus 4 plus 4 lambda plus 4 lambda square plus 4 minus 4 lambda plus 4 lambda square. Okay, so yeah, the only thing for this question is, I mean, it's not hard, but there's like a lot of calculations, so you need to avoid to do any careless mistake, right? Okay, so 1 4 4, so that's 9, and then minus solve, so you got 9 plus 2 lambda. Okay, then over 3, so for this part you have 1 4 plus 4, so that's 9. So 4 lambda plus 4 lambda, 8, 8 minus 4, so you got 4. Then the last one, 4 lambda square plus 4 lambda square plus 4 lambda square, so that's 12 lambda square. Okay, so you got the first one, then we need to repeat the whole thing again for the other angle that you are doing. So that's cos BOP. Okay, so cos BOP. Yeah, but for this thing, it's not going to be that long because you already have the OP thing, then you can just try to reuse it only. So for BOP is going to be OB, then times OP. Then the same thing here, OB and OP. Okay, so for OB is 340. Okay, the OP here is still the same. So 1 plus 2 lambda, 2 plus 2 lambda, 2 minus 2 lambda over magnitude for OB, that is 3 square plus 4 square. So for the OP part, yeah, don't repeat it again, yeah, because you already did it here. So that's why I can straight away take this. 9 plus 4 lambda plus 12 lambda square. Okay, so now let's try to simplify this. So we have 3 plus 6 lambda plus 8 plus 8 lambda plus 0 divide by 3 square, 9 plus 16, 25, so that's 5. Okay, and then for the top part, so we have 14 pi, for what I keep on saying pi, 14 lambda plus 11 over 5, then this thing. Okay, 9 plus 4 lambda plus 12 lambda square. Okay, so the question asks us to equate cos OAT and BOP together. So let's equate them. So cos for AOP equal to cos BOP. Okay, so let's try to copy the whole thing. 9 plus 2 lambda over 3, 9 plus 4. Oh yeah, now I realize it. Actually, if you straight away do it, you should realize that you have AP, then you doesn't really need to do the whole thing over. It's okay lah. Let's try to write down first, then I explain why. For 14 lambda plus 11, but I mean the answer itself also give that you need to show up to this point. So 4 lambda plus 12 lambda squared. Okay, so after you get this, then you can see you have the same part here. So that's why you can imagine you multiply the whole square root thing, you multiply the whole square root thing, then you just get, I mean, you can cancel off them, right? So 9, 2 lambda over 3 equal to 14 lambda plus 11 over 5. So cross multiplication, 45 plus 10 lambda equal to 42 lambda plus 33. So 32 lambda equal to this one go there, this one go here, so you get 12. So in this case, you have lambda will be equal to 3 over 8. Okay, yeah, so for this question, it's actually quite long to get the 5 marks. But basically, the knowledge that you need isn't that much because the question already give you what you need to do. The only thing that is that the working itself is super long lah. Okay, so the thing that you can get is, let me try to go through. Okay, the first one, so you will need to write down all your scalar products. So which mean the scalar product part, I'm going to put, okay, for example, the star here and the star here. So which means if you got all your scalar product correctly, like how you do this, it should be this part. Okay, how you do your scalar product. So if you got your scalar product, everything correctly, then you got your first M1. Okay, then the second thing is you are using everything like the cos equal to cos, so which means that is this part. Okay, for all your modulus part, you know how to apply this method and you get the whole thing correct here, then basically you can get M1 and then the other M1 here. Okay, so the whole thing correct, right? Okay, then maybe I try not to write like this. So you can try to note that your M1 is for if you use that equation. So you successfully to get everything here, then you can get your M1 here lah, basically. Okay, if you successfully apply everything here, so you can get your M1. So that's 1, 2, 3, and your last answer here is A1. Okay, oh, I think that's one more. 1, 2, 3. Using, oh yeah, the other one is for the modulus. Okay, so you can remember it as if you do your dot product, then you get your M1. It doesn't matter what's important is you got everything right. So dot product, you get M1. You successfully to do all the modulus, then you get M1. Then the other thing is you know how to use the full formula here, then you get your M1 lah. So basically that's the first 3 marks. Then after that, you equate them together, then you get 1. Then after that, your last answer, you get the other one. So this question, in total, you have 5 marks. Okay, so now let's move on to the next part. Okay, so see when when lambda has this value, verify that AP AP to the ratio of BP, then you get the same ratio for OA and OB. Okay, so you can imagine this is going to be a long working to show it as well because the idea is that when you try to look at OA and OB, right, they are not in the way that is just a scalar multiplication that easy because you can see the IJK here and the IJK here is definitely not in the form where you can write OA equals to like KOB, you get what I mean? So these two lines isn't parallel. So that's why what they mean here is basically the magnitude of AP to BP is the same with the magnitude of OA to OB. So this thing is going to be quite long, then I need to redo the whole thing again. So which means the first one, so this is part 3, is C, is it? Yeah. Okay, so maybe let's try to do the first one first, the easier one, so OA and OB. Okay, because this one we already have it from what we did previously. So OA and OB. Okay, so basically we are going to just compare it. Okay, so OA, we already know just now OA is 3, then OB is 5. So which means we need to prove just now that one is equal to 3, 5 as well. Okay, so the other one that's more complicated that you need to do like a long equation is for this one. So the thing is AP and BP. AP and also BPB. Okay, so for AP, you can straight away know it already because I guess just now we did do this. So AP, yeah, AP is lambda AB. Okay, so that's why you already have this part. So basically, you just substitute your lambda inside. So the lambda just now is 3 over 8. Okay, 3 over 8 and then multiply 2, negative 2. Okay, so from here, then you'll be able to get 3 over 4, 3 over 4, and negative 3 over 4. Okay, so after you get this, then the next one is PB. I guess this one is a bit, yeah, because you still need to plus them together. I don't think we have any PB before. Yeah, correct. So we might need to do that. Okay, so for PB, then PO plus OB. So PO just now is this one. Okay, so PO is like the negative of this thing. So -1 minus 2, 3 over 8. Okay, then the second one is -2 minus 2, 3 over 8. Then the last one we have -2 plus 2, 3 over 8. Okay, so this is the part for PO. Then for OP, you can straight away get it from the question already, so which is 3, 4, and 0. So now let's plus them together. You can straight away use your calculator to help you to do that. Okay, so 5 over 4, 5 over 4, and -5 over 4. Okay, so in this case, you don't need to do magnitude because by looking at this, then you should be able to know because 3 over 4, 3 over 4, -3 over 4, and they are just on the same line, right? So that's why the direction is the same thing. So they are just, what is that called? They are on the same line because you can imagine it's like AP, then you continue with BP, right? If you can write it in ratio way, then which mean that what you can try to do here is these two lines in the same direction lah. So we can no need to, I mean, if you want to find the magnitude also can, at the end you still able to get the same answer. But in this case, I guess we can just try to do, I mean, comparison here. So we can see 3 over 4, 3 over 4, 3 over 4. So which means in this case you can take out 3. So 1 over 4, 1 over 4, -1 over 4. So for this case, it's the same lah. So you can take out 5. So 1 over 4, 1 over 4, -1 over 4. So what you want is AP, BP, right? Okay, so that's why it's just going to be 3, 1 over 4, 1 over 4, -1 over 4, 5, 1 over 4, 1 over 4, -1 over 4. So in this case, you will be able to get the same thing as well, which is 3, 5. Okay, so which give you the same thing which OA and OB. So you prove that AP to BP is equal to OA and OB. Okay, so basically the thing that you need to show is, I mean, show that it's 3 to 5 and show that your method, everything here is correct. Yeah. Okay, so I guess for this thing, they are not too particular in because I mean, the marking key only give that verify the given statement correctly or perform the relevant calculation of the ratio. So basically, it's just for you to get the ratio and show that they are the same, then you get the 1 mark here. Yeah, but I guess it's actually quite a very long process for you to get the 1 mark here, but basically that's the idea lah. Okay, so now let's go on to number 5. Okay, question 5. The complex number z is defined as z equals to 9 square root 3 plus 9i over square root 3 minus I. Find and show all your working and expression for z in the form of the exponential form. Okay, so let's try to do A first. Alright, so you should be quite familiar with this. So the first thing that we need to do is to rationalize this thing first. So we have z is equal to 9 square root 3 plus 9i over square root 3 minus I. Okay, so multiply with the conjugate. So we have square root 3 plus I. Alright, so let's try to expand it. So we have 9 square root 3 times square root 3, so we get 27. So plus 9 square root 3i plus 9 square root 3i and plus 9i squared over square root 3 times square root 3 we get 3. Though, so minus and plus you get nothing there, then minus I squared. Okay, so we have 27 minus 9, that's 18, and then plus 18 square root 3i over 3 plus 1, that's 4. So let's try to simplify it. So 2 over, 9 over 2 plus 9 over 2 square root 3i. Okay, so after we rationalize it, then now we can try to find the component that we need. So let's start with r, which is the modulus. So modulus of 9 over 2 square plus 9 over 2 square root 3 square. Okay, so for this part we'll be able to get 81 over 4 and then plus square root 3, so 81 over 4 times 3. So that's going to give us sorry, oh yeah, that's right. So 2 4 3 over 4. So when you try to plus them together, 81 plus 243, that's 324 divided by 4, 81. 81 square root, so that's 9. Okay, so after you get this, then now we proceed to the data. Alright, so I hope that I still remember how to do that. Yes, so shift tangent, tangent -1. So the y part is 9 over 2 square root 3 over x is 9 over 2. So from here, then we'll be able to get inverse tangent square root 3. Okay, so by using calculator, and we'll be able to get pi over 3. So in this case, which means we'll be able to write down our z. Sorry for that. Okay, so z will be equal to 9e pi over 3i. Okay, so that's the answer. So now part B. Yeah, so this is the question that I want to discuss. So find the two square roots of z given your answer in REI data. Okay, so the first thing that you can try to do is, of course, if let's say you want to let your square root so to become x plus yi, then after that you square it. So like how you do how you do it normally by using the component form. So the other thing that you can try to do is you can straight away use this answer to do that as well. But you need to be a little bit careful, which is what I want to discuss here. Okay, so you are going to do you are going to find the square root of z, right? So the thing that we need to do is we only can find the positive thing by using z, because we know that if let's say we want to find the, so this is for square root of z. Okay, so it will be equal to positive and negative 9e pi over 3i, right? So for the positive part, it's actually easy, because what you need to do is you just, the first square root will just equal to square root 9e. So this is for the positive one. Sorry, let me try to write better way. Okay, so pi over 3i. Okay, so this will be equal to 9e pi over 3i and to the power of 1 over 2, right? So when you reach here, then you should be able to continue to solve it because square root of 9, you can get 3. Then after that, for this term, you just multiply them together. So you can get e pi over 6i. Okay, so this will give you the first answer. Okay, so now what happened to the negative? Because you wouldn't, I mean, you cannot do negative 3, please remember, because for this thing, you should be able to know that for the magnitude, you wouldn't able to have negative magnitude. Like the size of the, I mean, complex number, it cannot be like a negative number. So that's why, what's the only difference when you can see? So if you can recall from the previous part, right? Okay, or let's try to talk about this. If let's say we have this is a notes part, you doesn't really need to write it in your, I mean, in your working, but I'm just trying to explain it. Okay, so we know that if let's say we have square root of z, okay, so this thing will eventually give us two answers, right? The first one is going to be like negative, sorry, if let's say the first one is a plus bi, then the, okay, let me try to do it like this. If square root z is equals to a, then which means at the end we'll be able to get negative a and then a. Am I right? So you will have two answers like square root 9, then you will have positive, negative. So you'll have square root 9, then it will be equals to negative 3 and positive 3 like that. Okay, so when you try to do this, then it's going to be the same thing. But what we are trying to do is that you try to look at this. So can you tell me by looking at the argument and the size here, right? Which quadrant is this complex number its place? So when you try to look at this, then this is with a magnitude of 3, then the argument is pi over 6. So which means when you try to look at the argument, then which means that it's supposed to be like here. So the magnitude is 3, and then you're going up here is pi over 6. Am I right? So that's why for this thing, it's supposed to be a plus bi complex number. So what is the other pair of these square root? Is supposed to be negative a plus bi, right? So from here, then you'll be able to get negative a minus bi. So which means it will tell you that the other answer should be at the third quadrant here with the same 3 and then pi over 6. It's just that in different quadrants, so that's why you have the negative answer. So how do you find the other one? The magnitude doesn't change, then the other thing will be equal to, so this is your second one. I cannot write negative, but yeah, maybe just try to do the second. This is the first. Okay, the first square root will be equal to this. Okay, so now this is the second one. Okay, so square root, so no need to write the root. Okay, so square root of z equals to this. Okay, so the second square root here will be equal to the second one in this quadrant. So you see the magnitude is still 3. The only thing is that the argument changed. So how do you find this argument? Is basically you negative, because if you can remember, right, this thing must be in negative pi to pi. So that's why, which means if let's say we want to find this, then it will be negative pi and then plus pi over 6. Okay, so this answer is in quadrant 3 lah. So 3e negative pi, so negative 5 pi over 6i. So this will be your second answer. Okay, so the answer here will be given in the form if you give the first one, then after that the working, then after that the last one. So this is 3 marks. So then after that for question 1 here, then you will have you do your rationalize, then you get your M1. Okay, then you are able to continue to do everything until you obtain the correct denominator. Okay, yeah. So which means you should be able to get your use I square equals to negative 1. Then you can get everything. You can do your working here. Then you get the other M1. So if you are able to get up to 9 over 2 plus 9 over 2 square root 3i, then you'll be able to get A1. Okay. Then when you continue, you find the modulus and you find the argument, then you can get M1. Then you get your last answer correct, then you can get A1. Okay. So just a very quick one to continue this. So which means that you can try to imagine, let's try to do the other example. Okay. So if you get the other square root as maybe 5e, and then let's try to do, okay, 3 pi of 3 pi over 2, sorry, 3 pi 2 pi over 3, okay, 2 pi over 3. Then can you tell me what is the other square root? Okay, so same thing, the magnitude doesn't change, right? So you need to go back to the quadrant thing again. So for this thing, the magnitude is 5. So magnitude is 5, but your argument is 2 pi over 3. So which means is, I mean, over pi over 2 already, right? So that's why it's like, this thing is 2 pi over 3. Okay, so that's why in this case, then magnitude 5. So where is your the other one? So if you're trying to write it in a plus bi, then this should be negative a plus bi. Am I right? Because you are in this quadrant, so this is supposed to be a negative value than positive for y. So your the other square root supposedly to be in quadrant 4 now. So which means that it's supposed to be a minus bi. So for your answer later, it should be 5. The magnitude is still the same. So for this one, it's going to be your reference angle here, lor. So which is going to be only your pi, then sorry, negative pi, and then plus 2 pi over 3, and that give you pi over 3. Okay, so that's your the other answer. Alright, so that's basically how you try to do it in exponential form. Okay, so that's pretty much the part. So I hope that you can get it. So now let's move on to the next question. Okay, number 6, the variable x and t are related by the differential equation e to the power of 2x dx dt equals to cos square x when t is greater or equals to 0. Okay, so when t equals to 0, x equals to 0. So A, the question wants us to solve the differential equation. Okay, so the first thing that we need to do is rearrange the whole thing. So let's try to copy the question first. Okay, so let's try rearranging. So that's why you have dx here. So we move all the dx, all the x term to one part, then the t1 to the other part. So which means here, then what we have is 1 over cos square x dx. Okay, then equal to, for this part, you have 1 over e2t dt. And don't forget, now you need to start your integration, right? So remember to put down your integration mark. Okay, the symbol. Okay, so now we can continue. So 1 over cos square, we can just change it to secant square. So make sure you still have your integration here because you didn't start the integration yet. For this one, let's just try to change it to index form only. So negative 2t. Okay, so now we can start our integration. It isn't that very difficult. So the thing is you know to do the first two steps, then basically you know how to continue already. So integrate tangent square x, then you have tangent x, then equal to e2x, so negative 1 over 2e negative 2t. Okay, remember this one is divide by the derivative here, not multiply because you are doing integration. Okay, so now don't forget plus c. Okay, so let's try to solve it because you are given t equals to 0, x equals to 0. So tangent t, tangent 0 equal to negative 1 over 2e negative 2 times 0 plus c. Okay, so in this case, then this will give you 1. Tangent 0 is just 0, so that's why c is equal to 1 over 2. So let's try to rewrite it. So we have tangent x equal to negative 1 over 2e negative 2t plus 1 over 2. So the question want your answer, obtain an expression of for x in terms of t. So you need to bring the tangent to the other side. So tangent negative 1. So yeah, I guess no need to rearrange this. Alright, negative 1 over 2 negative 2t. Okay, so you can just leave your answer like this. Okay, so that's the part for A. So now B state what happened to the values of x when t becomes very large. Okay, so same thing. Either you want to just press with your calculator, increasing your t slowly, then after that check what happened to your x. So the other alternative that you can try to do in this case is to so to change this. So we know that for when your t is approaching to infinity, because it's getting larger and larger, right? So that's why in this case, this is supposed to be 1 over, so is e to t. Okay, so this thing will go to infinity as well. Then you have negative, let's do the positive one. Okay, so you have 1 over 2 e to t. So imagine when this thing goes very big, when you do fraction 1 divide by a very big number, so this fraction will approaching to 0. So that's why the x will just approaches to tangent negative 1 over 2 minus 0, which is basically tangent negative 1 over 2 lah. Okay, so in this question, they actually straight away accept this answer, so it doesn't really need to continue to solve that. So if you continue, then you can get 0.463, but that's not required in this question, so you can leave your answer here. Okay, but then the question here is B1, so I believe if you, if you continue to do like x approaching to 0.4636 4, they are still going to mark the first thing last, so which means the answer is given here. So this is your B1. So that's 1 mark for this question only. Okay, so yeah, since I already changed the pen, so I'll just note down for the first part. Okay, so you separate the variable, make sure you write down the integration sign, then you'll be able to get B1. So you successfully integrate, you know what to do, you get second square, then after that you can get tangent x, then you get b1. So you know how to integrate the exponential, then you get another b1. So by substituting x equals to 0, t equals to 0, then you are able to get your constant, then you'll be able to get your m1. So after you find it, then you substitute it back it to the equation itself. So which means by getting this thing, then you'll be able to get a1. So arranging it in the form of x equals to what, then you get the other a1. So for this question is 6 marks. Okay, so let's move on to the last part. Explain why x increases as t increases. Okay, so in this thing, then you can just try to check out with this equation lah. So yeah, I'm just going to write down the form that's given first, then from there I try to explain it. So you are given the e2x, e2t, is it? e2t dx dt is equal to cos square x. Okay, so from here then we can try to rearranging it. So which means I can always do dx dt is equal to cos square x over e2t. Okay, so this is the rate of change of x with respect to time. Am I right? So that's why you can look at this. So when x increases, when t increases, x increases, meaning in a form where your gradient is always an increasing gradient. So what you need to prove is that dx dt is always positive. So how can you do that? Because of this thing, we already know that e for any exponential, it will be always positive, like greater than 0. So for cos square x, because it's just basically cos x, then you square the whole thing, right? So cos square x is going to be greater or equal to 0 as well. So you can imagine for this thing, your dx dt. Okay, so when you try to use a number that's greater or greater or equal to 0 to divide by a number that's greater than 0, then you should be able to get a number that is always positive as well. Okay, so that's yeah, actually you solve it until here, then so because dx dt is a positive, yeah, you can try to write down. So dx dt always positive. So that's why you also know that when t increase, then your x will increase as well lah. So yeah, that's the idea. So the thing that you can try to do in this is only 1 mark, so that's why it's given for your justification only. So as long as you can prove that this thing, when you combine them together, is always greater than 0, then you can get the marks. Okay, so basically that's the idea. So 1 mark. Okay, so now let's look at question 8. Okay, question 7. By sketching each of the graph y equals to cosecant x and y equals to x multiply pi minus x for a range from 0 to pi, so show that the equation has exactly two real roots for this equation. Okay, so let's try to sketch the graph. Yeah, so I've put down the, axis, so to ease my work here. Okay, so the first one is y equal to cosecant x. So for this one, you should able to know how to draw this thing. So it's the inverse for sine graph. So it looks, sorry, let me try to draw a better one. Okay, so this is a cosecant graph. So you should having like the minimum point at pi over 2, and then the y here is 1. Okay, so now let's try to draw the second one is y equal to x, then pi minus x. Okay, so from here then you will be able to know that if let's say when x is 0, then y will be equal to 0 as well. Okay, so the intersect is 0. Then after that, when y equals to 0, that's 2x, then definitely the first one is 0. Then the second one is going to be the pi here. Okay, then the last thing is this is a quadratic, so because you can get y equals to pi x minus x squared, right? So it's a negative quadratic. So you already know that this thing is, is a negative quadratic. So this graph will pass through the point of 0, 0 here and 0 pi. So that's why you can find out the maximum here, which will be the half of 0 and pi. So which means for the maximum point here, it will be equal to pi over 2. Then you substitute back pi over 2 here. So pi minus pi over 2, you get pi over 2 times pi over 2, then you can get pi square over 4. Okay, so then you can try to use your calculator to check pi square over 4 is roughly 2.5. So that's why it should be higher than this. Okay, so which means that this graph is a negative, so which means it's supposed to look like this. Sorry, yeah, so basically you will have a maximum point maybe roughly here. Okay, so let me try to just draw it. Okay, so I hope that you can draw a better one, but basically that's the idea. So 0, 0, you pass through here, and then the maximum point is at pi over 2 as well. And then after that, this is pi square over 4. Okay, so basically that's the important thing that you need to show. So in this case, you need to show that has two real root. So that's why this is your first one. Okay, then this is your second one. Then you can just write that. So two intersection points. So that's why that's two intersection, two roots. So two intersection point. Okay, for y, it's okay lah, no need to write so long. So two intersection point. So therefore two roots. Okay, so the marks here will be given for, the shape of your graph. So if you have your graph correctly, everything here, so which means you get your B1 here for the first graph, then your second one is another B1, then justify the statement here. So the thing that you must make sure is you must have this maximum wealth, because the thing that you need to show is that is if only your maximum point for this curve is higher than this, so that's why you will intersect at 2. You get what I mean? If let's say you didn't get this maximum point, right, then maybe your negative quadratic graph will just below this thing, then you wouldn't be able to intersect at 2 point. So that's why for this justification, right, except you need to state that you have two intersection point, you also need to include the maximum point as well. So which means by looking at the graph, I should be able to look at what is this and then what is this. So for your justification, then only you can get the last one here. Okay, so that's a 3 marks question. Oh yeah, and don't forget, sorry. So for this part, try to note down the graph that you try to draw. So cos y equal to cosecant x for this one. Then for this one is y equal to x pi minus x. Okay, so try to label the graph. Okay, so now part B, show that equation cosecant x equal to x pi minus x can be written in this form. Okay, so this is some rearrangement by using trigonometry. So let's start with that. So that's B. Okay, so we have cosecant x is equal to x then pi minus x. Okay, so you can see in what you want to show here, you only left with sine. So what they try to do here is they try to change the cosecting, right? So which means the first thing that we can try to do is 1 over sine, or you can just try to do sine x. Okay, then you feed this thing. Okay, so you'll be able to get 1 over x and then pi minus x. Okay, so after you got this, then bring everything to the right hand side. So sine x might multiply x, then you have x sine. Let's try and do it. Yeah, x then pi minus x. Okay, then equal to 1. So in this case, then when you try to look at it, then I think you need to expand it first. So x pi sine x minus x squared sine x will be equal to 1. Okay, so we are very near to the answer already. So x pi sine x will be equal to 1 plus x squared sine x. Okay, so you bring the whole thing over to the other side and then you're left with x. That's right. Okay, so x will be equal to 1 plus x squared sine x over pi sine x. Okay, so that's how you prove it. Yeah. Okay, so now part C. This is iteration yes. Okay, so there's two real roots in the interval from 0 to pi. So as what you can see here, from 0 to pi. So where alpha is bigger than beta, so which means the first one is going to be alpha, then the second one is beta because the question give you alpha is lesser than beta. So try to use the iterative formula to find alpha first. Okay, so for this part, I'm just going to fast forward it. Yeah, but before that, let's try to go through for this part first. Yeah, so for the marking key, you will be given 1 mark if let's say you understand that cosecant is 1 over sine x. So you is either you try to write 1 over sine here or you try to flip this around, then you'll be able to get m1. Okay, so everything you show everything correctly until you get your last answer, then you'll be able to get your a1. Okay, so that's the 2 marks. Okay, so now part 3, which is the part C, I'm just going to fast forward that. Okay, so same thing. I don't think I need to repeat it again. So every time it's the same thing. So if you know how to use it for at least one time, then you'll be able to get your M1. So you complete everything, do it for 4 significant figure until you get your last answer, write it into significant figure, then we'll be able to get A1. So show enough iteration. In this case, I think I try to do 1, 2, 3, 4, 5, 6, 7. Yeah. Okay, so make sure you show enough iteration, or the other thing is you try to use your checking lah. So for this case, so like what I always say, so try to normally just do both lah. So your M1. Okay, so that's 3 marks for this question. Okay, so now move on to part C. So this is how you get your answer alpha as 0.66. So like what I mentioned just now, this is your alpha, right? So now you need to find your beta. So which means you can see the distance between here and here should be the same, here and here should be the same. So how can you find this value? You use your pi, then minus off the value that you got just now. Okay, so which means this is D. Okay, so for the question, I think the question also want your answer in 2 dp only, so that's okay if you just use the answer that you have here. So beta will be equal to pi, then minus of 0 point. If you can, then you can just try to put in 3 lah, but at the end, you only need to provide your answer in 2 dp. So 2.48 radian. Okay, so for this question, it's only 1 mark. So basically, if you get your answer, then you have that 1 mark. Okay, so yeah, that's the part for question 7. So now let's look at question 8. Okay, question 8, show that x plus 1 is a factor of 4x cubed minus x squared minus 11x minus 6. Okay, so we can try to use factor theorem. So prove that the remainder is 0. So that's why x plus 1 is a factor. Okay, so question A. So let fx equal to 4x cubed minus x squared minus 11x minus 6. Okay, so f negative 1, and let's check. Square minus 11, negative 1 minus 6. So we have negative 1, negative 4 minus 1 plus 11 minus 6. Okay, so negative 5 plus 11, that's 6, 6 minus 6, then you get 0 lah. Okay, so from there, then you know that, so x plus 1 is a factor. Alright, so for this question, the thing that you need to do to substitute substitute negative 1, then after that you get your last answer as 0, then you got 2 marks. Okay, so now let's move on to the next part. So B, find the integration for this thing. So when you try to look at this, then you should be able to know the first thing that you will need to do is you might need to do partial fraction here. You need to do long division, then you need to find out what's the possible factor here, because for this case, you will realize that the denominator is exactly the same with part A. So which means they help us to find out one of the factor already, then we need to find out the other factor. Then you try to expand it to partial fraction. Then after that, you only use your partial fraction and do your integration. So that's why you can imagine the process is quite long. So that's why it's 8 marks here. So the idea is actually not long, not very difficult, but there's a lot of steps to do lah. Then just make sure you do not have any careless mistake in any of your process. Okay, so now let's start with our to find out the other, what is that called, the other factor first. Okay, so in this case, then we will have, let's try to do comparison, I guess. So 4x cubed minus x squared minus 11x minus 6 will be equal to, so first one that we have is x plus 1. So let's try to use the other one, ax squared plus bx plus c. Okay, so let's try to solve this. So for x cubed, then we have 4 equal to a. Yeah, so you can get the first one already. Then by looking at x0, then you'll be able to get the c is equal to negative 6. So now you're left with the b part. So let's try to look at x squared. So we have negative 1. And then for this part, equal to, okay, then we have x times x times bx, so that give you b. Then after that, x times no more, so plus 1a. So let's try to substitute a, so that's 4. Okay, so b is equal to negative 5. So in this case, then we can try to see 4x cubed minus x squared minus 11x minus 6 is equal to x plus 1. Then a is 4x squared minus 5x minus c is 6, is it? Yeah. Okay. So after you get this, then now let's see whether you can expand this or not. So x plus 1, you should be able to do that. So 2, 2, 2, yeah, no, I guess you need to use 4, 1. Okay, 4, 1, then after that 3 and 2. So 3 and 2, 3 and 2. Yeah, 3 and 2. Okay, then after that minus this one is plus. So 4x plus 3, and the other one is x minus 2. Okay, so after we get this, then now we can proceed with partial fraction. So yeah, this is only the first step. So let's move on. So 4x squared plus 9x plus 1. Okay, then equal to, then let's expand this part. So we have a over x plus 1 plus b over 4x plus 3 plus c over x minus 2. Okay, so now let's try to multiply with the denominator. So we have 4x squared plus 9x plus 1 will be equal to a, and then 4x plus 3, x plus 2. Just make sure you are, careful with all this long working thing, because it's supposed to be an easy thing, but yeah, eventually you're easy to get it wrong as well because it's very long. Okay, so 4x plus 3. Alright, so after you get this thing, then now we can try to do some substitution and to get our new ABC here as well. So in this case, let's start with x equals to -1. So 4 -1 squared plus 9 -1 plus 1 equal to a 4 -1 plus 3. Oh, sorry. -1 minus 2. Okay, so try to expand this. So 4 minus 9 plus 1, and from there we'll be able to get -6. So equal to a. So -4 plus 3, so that's -1, so -3. So from here we get 3a equals to -6, so a is -2. Okay, so same thing. Let's move on for x equals to the second one, so -3/4. Alright, so yeah. Okay, so for this part we are finding b. It's 1 -3/4 minus 2. Okay, so for this part we have after you calculate everything, then you have -11/2, so equals to b. So for this part plus 1, then we have 1/4 -11/4. Okay, so when we combine, we have -11/16. So divide, then you got b equals to 8. Okay, so move on. Next one, x equals to last one is 2. So 4, 2, 2 plus 9, 2 plus 1 equals to c, 2 plus 1, 4, 2 plus 3. Okay, so 16 plus 18 plus 1, 33 equal to c, then we have 3 and 11. So this gives us c is equal to 33. Okay, oops, sorry, 33, so C is equals to 1. Okay, so after you get this, then now we shall be able to proceed everything already. So yeah, if you want, then you can, yeah, I guess we can straight away write it into the integration thing. So integrate your 4x squared plus 9x minus 1 over 4x cubed minus x squared minus 11x minus 60x will be equal to, then we write down our partial. Okay, so A is negative 2 over x plus 1 plus B is 8 over 4x plus 3. Then the last one plus 1 over x minus 2. Okay, so now let's try to split it. Then we try to arrange it in a form where f prime x over fx, then it will help us in our working later. Okay, so x plus 1, you know that later when you try to when you try to differentiate your denominator, and you should be able to get 1, so you can take out negative 2. Okay, so 1 over x plus 1 dx. Okay, plus, so for this part, after you differentiate this one, you should be able to get 4, so you can take 2 outside. Then the last one here, I guess that doesn't, yeah, so x is just 1 lah, so you can just copy. Okay, so now we can start our integration. So we have arranged all in the term of f prime x over x, f prime x over x, f prime x over x. So I can just proceed. So ln x plus 1 plus 2 ln 4x plus 3 plus ln x minus 2. Okay, and don't forget your plus c. Alright, so that's basically the answer. So let's try to look at the 8 marks. How is that given? Okay, so the first one, you will need to get your quotient. So which means in this case, the 4x squared minus 5x minus 6. So this gives you your A1. So if you are using, no matter you are using comparison or you are using long division. Okay, so no matter which one, then you'll be able to get your method mark so that you get the other quotient here. Then you try to expand it. So in this form, then you can get another A1 here. Okay, so and you try to continue to able to solve everything here. So after you're able to get all the 3 value, so all the value for A, B, C, then you'll be able to get 2A1. Okay, if you are able to get only one of it, then yeah, you have 1 lah. Then if you're able to get all 3, then you have 2 marks. Then after that, you are able to put them everything together, then successfully to do your logarithm. So you know how to do, how to change, integrate to obtain 3 terms each involving natural logarithm. So logarithm, yeah. So which means from here to here. Okay, then you'll be able to get your method marks. Okay, then lastly, so make sure you have all the modulus that you need and plus C. Then the last one, you have your A1. So this is how the 8 marks is given. All right, so let's move on to 9. Okay, question 9 is, so yeah, this is a trivial question. So show that 2 second 2 theta cos theta equal to cos second square theta. Okay, so let's try to use the identity. Okay, 2 second 2 theta cos theta. Okay, so you can see basically everything is you need to convert to the basic first, then later, because now you left with theta only, so which means this part later you will need to expand it as well. So which means in this case we have 2, then cosecant 2 theta is 1 over sine 2 theta. Okay, so cotangent, then you can change it to cos over sine, because you can look at this thing, it doesn't have any tangent anymore, right? So cos over sine. Okay, so now let's try to change this. So we have 2 over sine 2 theta is 2 sine theta cos theta. Okay, and then continue cos theta sine theta. So in this case, you can see cos theta, you can cancel off, then 2 and 2, then you left with 1 over sine square theta. So yeah, try to change it, then you have cosecant square theta. Okay, so I guess this is actually not too hard. So the marks will be given if, let's say, you identify sine theta here, then you are able to change it to 2 sine theta cos theta. So attempt to express everything in the term of sine and cos only. So this one you get a method mark. Okay, so this is B1. Like you state this up basically if you are able to identify this and you change it to 2 sine theta cos theta, then you get it. Then you simplify everything, the process until you get your last answer, then you have your A1. Okay, so now part B, show that cosecant square 15 tangent 15 equals to 4. Okay, so this question is a bit similar like what we did previously. If you remember in the difficult set 1, you also have this similar question. Okay, so let's try to just rearrange the stuff. So 2 second 2 theta cotangent theta equal to cosecant square theta. Okay, so you can see this thing is cotangent square 15 then tangent 15. So which means what happened here is you might need to move this to the back. So this is 1 over tangent, right? So you can straight away move tangent lah. So which means 2 second cosecant 2 theta equal to cosecant square theta tangent theta. Okay, so which means in this case, we try to let our theta equal to 15. So when we try to solve it, then which means cosecant square 15 multiply tangent 15, it will be equal to 2 cosecant, then 2 multiply with 15. Okay, so we have 2 cosecant 30. Alright, so use your exact value that you know, 2 over sine 30. So sine 30 give us 1 over 2. So 2 over 1 over 2. That's basically give you your last answer equal to 4. Alright, so in this case, the first thing that you need to do is to identify that you need to use what is given in the question here. So you are able to identify and express everything in a form of 2 second 30. So which means for this part, then you'll get your M1. So it's successfully to get 2 over, okay, so the whole thing here, then it will allows you to get to A1. So that's 2 marks for this question as well. Okay, so now part 3. Okay, part C, solve the equation 2 cosecant phi cotangent 1 over 2 phi plus cosecant 1 over 2 phi equals to 12. Okay, so yeah, this is solving equation and you'll be able to realize that this thing and this thing, they are similar. Okay, so it's the same thing it's a continuous of question. You need to use what you have in part A, then you continue to use it. So the idea is if 2 theta equals to 5 and theta equals to 1 over 2 phi, then which means that this thing will equal to 1 over 2 phi lah. So that's the idea. Okay, so let me try to just copy the equation first. So this is part C. Okay, so 2 cosecant phi cotangent 1 over 2. Alright, so I hope you get what I mean just now. So which means in this case, yeah, you'll be able to see this and this is the same. So this divide by 2, this one divide by 2, so this thing also divide by 2. So now we use this to substitute into this part and we change it to cosecant squared, then 1 over 2 phi lah. Okay, so I hope that you get what I mean here. So let's try to just substitute here, then we get cosecant square 1 over 2 phi plus cosecant 1 over 2 phi equals to 12. Okay, then the next thing that we can try to do is multiply the whole thing. Okay, so we want to change it to sine because it's hard if we want to, dealing with it in cosecant. So cosecant is 1 over sine. So if you are not familiar, then what you can try to do is you just change everything first. 1 over 2 sine square, okay, plus 1 over sine then equal to 12. Okay, so the whole thing multiplied by sine square 1 over 2, 5. So you have 1 plus sine 1 over 2, 5 equal to 12 sine square 1 over 2. Okay, so now rearranging them. So this is just a quadratic basically. So 12 minus. So I mean, if let's say you find it's very confusing to look at this, right, then what you can try to do is you just change it to, like, for example, a equals to sine 5. Okay, so you solve for a, then after that you just come back to this lah, but basically they are just the same thing. So in this case, then you have 4, 3, and 1, 1 lah, so negative plus. Okay, so which means 4 sine, sorry, I think I left out this 1 over 2. Okay, so 4 sine 1 over 2, 5 plus 1 multiply 3 sine 1 over 2, 5 minus 1. Okay, so now we can solve it. So which means in this case, we will have sine 1 over 2. Let's copy the whole thing first. Plus 1 equals to 0. Okay, so let's solve one by one maybe. So in this case, we have sine 1 over 2, 5 equal to negative 1 over 4. Let's try to look at the question. Okay, so they want your answer to be from negative 360 to 360, and you are solving 1 over 2. So which means that your answer later, it should be in between the range here. I'm just going to write here, right? Okay, negative 180. That's no equal to. Okay, so you are solving for this thing. Alright, so now let's try to look at this. So this is from quadrant 1, 2, 3, 4 as well, but it's just positive, you go to 1, 2, negative, you go to 3, 4. So for sine negative, it's going to be quadrant 3 and quadrant 4. So which means in this case, 1 over 2, 5 will be equal to the first one. So for the reference angle, you'll be able to get 14.48. So that's quadrant 4 as well. So negative 14.48. Second one, it will be quadrant 3, so negative 180 plus. I hope that you get what I am doing now. So, I mean, you have the quadrant, right? So, positive 880, that's AS. So, that give you both positive. So, now you need negative. So, that's why from here to here is 1. Then the other one is from here up to here lah. Okay, so you find the reference angle. So, this is your negative, your reference angle. So, for this one is negative 180. Then you plus this one, then you can get the angle here lah. Okay. So yeah, when you continue, then for this part you have negative 14.48. Second one is negative 165.52. Alright, so your last answer in degree should be in one decimal place. So that's why negative 29.0 times 2, right? Then the other one is negative 331.0. Okay, so that's the first part. That's not the end yet. You still have the other part. Yeah, don't forget that. So 3 sine 1 over 2 minus 1. Okay, so this is the one that give you positive, that you need to go through the positive region. So sine 1 over 2 equal to 1 over 3. Okay, so same thing, your calculator, but then you now go through here, first quadrant and also second quadrant. So 1 over 2, 5. You have 19.47, then the other one is 180 minus 19.47. So you can get your answer 19.47. The other is 160.53. Okay, so your 5 here times 2, 1 dp, 321.1. Alright, so yeah, that's your answer basically. So if you want to rewrite everything again, then just copy it again lah, but I don't think that's necessary lah. So just copy down all your answer, but basically that's the thing that you need to do. Okay, so let's try to go through the marking key for this part. Okay, so the first thing that you need to identify is you know how to change it to the quadratic thing. So which means that you are able to get it up to this point. So you can get M1. Okay, so you are able to solve everything by using quadratic until you can get this form. Then you'll be able to get your A1. So you continue your process, then you are solving for this one equals to -4, then until you get your last answer here, it will be equal to your method. Then after that, so this part is your method part. Okay, so it allows you to get 1 mark. Then after that, the method part here also allow you to get another 1 mark. So you will get the last mark if you got all your 4 value. Okay, all 4 and then no others. Okay, because sometimes the people, I mean, some of the students may not look at the question that the 5 should be in between -360 to 360. Then you put like other stuff like, or you only get 2 answer, then you'll be not, I mean, you'll not be able to get your last mark lah. Okay, so for this term, 1, 2, 3, 4, 5, so that's 5 marks. Okay, so now look at the last question. Okay, number 10, the parametric equation for the curve are given x equals to this thing, y equals to this thing. Okay, so I mean, when you try to look at this, then you can imagine later you need to do differentiation lah, because for your coordinate geometry and other parts, you doesn't involve any parametric equation. So basically, when you have this thing, then which means it has to deal with differentiation. Okay, so yeah, the curve crosses x-axis at point B and D, then the stationary point are A and C. Okay, so these are the maximum and minimum basically. Okay, so A, you need to show that dy dx equals to 2 over 3 cotangent 2t minus 1. Okay, so you see differentiation. So let's try to do the first one first. So x equals to 6 sine square t. Okay, so this one is, I mean, using a chain rule. So you will have, if you are not sure with it, then change it first. Okay, so you can see the pattern. Okay, so dx dt equal to 12, and then sine t power minus 1, so you don't have anything else. So remember, differentiate what's inside, so you got cos t. Okay, then for the next one, I think it's just normal trigo. So we have y equal to 2 sine 2t plus 3 cos 2t. Okay, so dy dt will be equal to 4, and then sine become cos. Cos becomes sine but negative, then 6 sine 2t. Okay, so by having this, then now you can proceed with dy dx already. So dy dx will be equal to dy over dt multiply dt over dx. So this thing has to be reciprocal. So this thing has to be reciprocal. So dy dt, just copy the whole thing. Okay, second part, multiply 1 over 12 sine t cos t. Okay, so let's try to see what can we try to do next. Yeah, because the question want to show cotangent 2t, then which means that the thing that you might need to think of, like how can you simplify is this thing, because now it's already in 2t, so we try not to change this first, but to change this, because we know that 2 sine t cos t is equal to sine 2t, right? So we can try to change that. So this thing is equal to, let's try to put them into numerator. Okay, you change to the form where you understand first. So 6 2 sine t cos t. Okay, so 2 sine t cos t is equal to sine 2t. Okay, so by now you should be able to see how should you continue already. So equal to 4 over 6, so you have 2 over 3 cos 2t over sine 2t, so that gives us cotangent 2t. Okay, then minus of, it's the same thing, so minus 1 lah. then we can get exactly what the question wants us to prove already. Okay, so now let's go through a marking key. So the first mark will be given if you get your dx dt, if you get your dy dt, if you are able to multiply them together and get your dy dx, then you are able to identify your 2 sine t cos t, and you are using the identity here. Okay, which means the sine 2t thing, the double angle formula, not identity, sorry. Okay, the double angle formula, then you are able to substitute or replace it, then you get it, then you try to simplify everything until you get your last answer. Okay, so that's basically the 5 marks of this question. Okay, so now we move on to the next part. So find the values of t at A and C, giving each answer correct to 3 decimal place. Okay, so in this case, A and C is given that it's your stationary point. So we know that for stationary point, the dy dx is equals to 0. Okay, so which mean B. Alright, so at A and C, so dy dx is 0. Right, that's A and C, right? A and C. Okay, that's correct. So now 2 over 3 cotangent 2t minus 1 equals to 0. So 2 over 3 cotangent 2t equals to 1. Alright, so you can bring this over to the other side. So you get 3 over 2. Then you change it to tangent, then you change it back again. So equal to 2 over 3. Okay, so after you get this, then you'll be able to solve it. So look at the, again, so this thing, you can try to see that t is between 0 and pi. So which means in this case 2t, then you are solving for 0 to 2 pi. Okay, so tangent 2t equal to your reference angle. So in radian, 5880. Sorry, this is 2 pi. What am I writing? So 0.5880. Then the other one is ASTC. So the second one, then which means it's going to be pi plus, okay, 0.5880. Right, then you'll be able to get two of your answers. So 0.5880. The other one is 3.7296. So your last answer T will be equal to, remember, the question want you to write your answer in 3dp. Okay, so that's your answer. Alright, so for this question is a 3 marks question. So basically what you need to identify is tangent 2t equals to 2 over 3. That give you 1 mark. So if you are able to get your answer until the last one, you will be able to get 1 mark for each. Alright, so let's look at the next part, the last part of the question. So find the value of the gradient of the curve at B. So B is here. Okay, so if we want to find the gradient, which means we need to find the dy dx. So if you want to find the dy dx, in other words, you need to find out what is your t first, so that you can substitute your t into your dy dx function, then only you can get the value of dy dx, right? So for you to get your t, then you need to refer back to the diagram here, so you can see when at b, your y is equal to 0, then you can substitute 0 here to help you to get your t. Okay, so y equals to 0. So something that you can try to do is you write down your dy dx first, then maybe later it's going to help you to, to know until which step you need to stop. Okay, so yeah, why is that so? Because of when you try to look at this thing, right, you have 2t here and you are going to do cotangent 2t. So later in any of your working, if you realize that you have tangent 2t, then you might able to actually stop there. You doesn't really need to solve until t, because later you are going to do, times 2 and you do tangent again. You get what I mean, right? So that's why in this case at B, the y is equal to 0. So that's why 2 sine 2t plus 3 cos 3t, 2t is equal to 0. Okay, so this is from the parametric equation. So after you reach here, let's try to put this to the right hand side. Okay, so yeah, you can see you can get the tangent equal to -3/2. So this thing is just tangent 2t. Okay, so you see what you need for you to do dy dx is basically to get cotangent. So that's why cotangent 2t is equal to -2/3. So from here, you get what you want already. So basically, you do not need to solve for t and substitute back again, right? You are just going to end with the same thing. So dy dx, so equal to 2/3. Cotangent is -2/3 minus 1. Alright, so in this case, -4/9 minus 1, and you'll be able to get -13/9. Okay, but of course it doesn't matter if you continue, I mean, if you doesn't realize this and you continue to solve your t, right, then you substitute back into the equation again, it's going to give you the same answer as well. Okay, so don't worry that much about that, but make sure that you use the exact value lah, because if you use a rounded value, then later you couldn't get -2/3, and that's going to make your answer less accurate. Okay, so let's go through the marking key. So for this one, then the first thing is you need to know that you need to equate this to 0. Then make sure you continue everything at least until the tangent side. Okay, so for the whole thing here, then you'll be able to get your M1. So the same thing, if you continue and get your T, then you can get it, or not, then you can get this thing, then you have your A1, then you substitute into dy dx, then you're able to get your last answer. So this is your last A1, so that's 3 marks. Alright, so that's basically the question for this set. Sorry, it's a bit long here, so I hope that you can understand what has been explained here. So if you still have any question, then you can feel free to ask me during consultation hour, or you just personally drop me a message. Okay, so all the best for preparation for your exam. So I'll see you when I see you in college. Okay, so take care and thanks for watching.